Welcome back to our past paper review, and we are still in Science Paper 1, 2020. Now we are going to question B2. Question B2 reads, a car has a mass of 900 kg. It accelerates from rest at a rate of 1.2 meter per second squared. So here in this question today, we are dealing with a car that is basically accelerating at a rate of 1.2 meters per second. Okay, so the first question there, they're asking us to calculate the time taken to reach a velocity of 30 meters per second. Okay, awesome. So every time you are dealing with calculations, what is going to help you are formulas. You need to be acquainted with the formulas. And this topic, basically, linear motions, you need to know those three equations of motion that I've just put on the screen. There are three equations of motions that are very, very important. All right? These three formulas must be your secret weapon in the exam room. So V, which is the final velocity, is equals to initial velocity plus acceleration times time, is the first formula. The second formula is S, which stands for distance. S is equals to ut plus half at squared. And the third one is V squared is equals to u squared plus 2as. Keep in mind that the s can be replaced with the x. It's one and the same thing. So if you know these equations of motion, you can pick any of the formulas that are suitable for that question, and then you will be able to answer all the questions under linear motions. Okay, so here we go. Calculate the time taken to reach a velocity of 30 meters per second. So the formula that you can use here to find the time taken is the first equation of motion. So the first equation of motion is actually the same formula as the one for acceleration. Acceleration is equals to V minus U over T. That's actually the same formula. We have just made V the subject of the formula. So in other words, we are using this formula for acceleration in order for us to find the time taken to reach a velocity of 30 meters per second. Okay, so according to our data, the final velocity is 30 meters per second because we are told that is the velocity that was reached. Now, this question, they're telling us it started from rest. It accelerated from rest. So if it accelerated from rest, it's important for us to realize that rest simply means the velocity was zero. The starting velocity was zero. So that is where this zero is coming from. Divide by the time is what we are looking for, so we will leave it as it is. We have the acceleration is already given in the question. As you can see there, 1.2 meters per second is the acceleration. So that has already been given. We already have the acceleration, which is 1.2 meters per second. All right, so we just replace that figure. So when you do the math, and you make T the subject of the formula, the answer that we get is 25 seconds. So the time taken to reach a velocity of 30 meters per second is 25 seconds, which is our answer. Question 2 says, calculate the force required to accelerate the car at a rate of 1.2 meters per second squared. Right. So again, it's a calculation. So you ask yourself this one simple question. What formula do you use, okay, to find the answer? So this is force. You should remember that force is given by the formula mass times acceleration. According to our question, the mass that we are dealing with here, according to our question, is 900 kg. And by the way, make sure the mass is always in kg. When the mass is in grams, first of all, convert it to kg. So this one is in kgs. The mass is just okay. There is nothing to convert. And our acceleration, of course, is 1.2 meters per second squared. So all you do is you replace the figures, 900 kg, you multiply that times 1.2 kg, 1.2 meter per second rather. And we get our answer, which is 1,080 newtons. So that is the force that is required. That is the answer for the second question.